Okay, these can always be problematic because somebody said, where do you start? And you start at the beginning. You start by reading it, and it goes on to say that you have numbers A, B, and C that are in geometric progression. So the first thing I would do is write down that A, B, and C are geometric progressions. The way I write this down is first term, just call it A. Second term, it's going to be A times some common ratio, and then AR squared. So that's my three terms over there. And then I kind of play around with it, but in order to play around with it, I think I have to recognize certain things before I go forward. And something to recognize there are relationships between terms that you may know about already. For example, geometric mean, things like that. But I know there's cubes and squares in this problem. So what I'd like to do is just kind of multiply things together. And I'm pretty sure I'll get cubes somewhere and squares somewhere. So like if you just did A times, let's see, A times C. Let me put that down. That's this one times this one. What would you get? A squared R squared. All right. That's so unusual, though. We were kind of expecting that with the geometric mean, right? And what is this really equal to? This is equal to B squared. I certainly see B squared in the problem, by the way. I do see that, all right? So I can say that's not so bad. What else could I do? I kind of look for a cube in the problem. And I get a cube. I guess what I could do is, maybe, maybe I should also do A times B. Now, if you did A times B, it's kind of unproductive. You just get A squared R. So I'm going to say that really is not what I was looking for. So I'll erase that. But I want to try the A times the B times the C. Oops. A times the B times the C. And what do I get there if I do that? Well, the A is A. The B is AR. Again, I'm looking for a cube now. And then you get AR squared. And what does that give me? Well, that gives me A cubed R cubed. So I got two really simple facts over here. That AC is B squared, a square. I see it in the problem. And ABC is B cubed. This is good, all right? Because I see cubes in the problem. I see squares in the problem. So then comes the issue is, what are you going to do about that? And I got to do something. I got to erase this stuff I'm highlighting over here. And what I would say is pick a side. And what you're going to do, just like you've done and maybe other proofs, is you're going to pick one side and you're going to try to work with that side to see if you can get the other side out of it. All right? This is what's known as verifying an identity. They're claiming it's an identity. So let's take a look at it. And I'm kind of looking at it. And the first thing I want to notice about this thing, if I chose this side here, right, I'll put this over here. And let's see what you get. Well, you get A cubed. We'll talk about that later, by the way. B cubed. We'll talk about that later. Plus C cubed. But I'm really kind of concentrating on that bottom, and I'm definitely seeing the ABC. I'm definitely seeing it. But what do I see? It would be ABC is actually B cubed, but that's squared, so it's B6. Well, you know what? It's still not the other side. But I got at least one of the terms. But the other two I didn't get. But I'm getting hopeful. What do I get over here? A cubed over 6 plus 1 over B cubed plus C cubed over B. I'm sorry. This is B6. I put 6 there. It's B6. All right? By the way, I want to get my eraser out because I'm pretty sure that I need to do more work. But I want to get my highlighter out. And I want to tell you again what I'm looking at. I'm looking at this. And I'm looking at this. All right? And I got to do something, though, don't I? And let's take a look at this over here. And I'll kind of use, I'm using one fact at a time, so to speak. So I'm going in this direction over here now. Let me put the next thing down. Equals, well, I got something over here, don't I? And let's put this over here. This is going to be A cubed over B cubed what would you get next? I gotta be careful about this, don't I? I'm looking at this. You know what I'm gonna do? Let me do something different. I definitely got the middle term though. I'm gonna write this down instead. A over B squared cubed plus 1 over B cubed plus C over B squared cubed. All right, now do you know what B squared is? It's AC, right? So what do you get over here? You get A over AC cubed plus 1 over B cubed plus, this would be C over AC cubed. Again, we're still going forward. I don't know if I'll get there. But what do you get over here? Well, the A's cancel. So what do you get? 1 over C cubed. The middle term was really kind of a miracle. It worked right away. And what do you get for the last term? The C's cancel. You get 1 over A cubed. Right now, we're at the end. Q, E, D. What did we do? We got that side. All right? Now, someone says, what if you took the other side and did the same thing? You could. All right, you could. So what I want to do is I just want to remind you, I'm using a couple of facts here. I'm using AC is B squared. That's something we're using. And I'm using ABC equals B cubed. All right, now this is why you're doing those. It's something that we need. All right? So someone could say, well, this is what we just did, by the way. Now, granted, it might be more work over here. You might say you did less work over there. It's up to you. I mean, I can't say everyone's work looks the same, or my work looks the same after I do a problem. But I want to do the other side. And so what we're trying to do the other side is we have this, and we're trying to show this now. So before I do, I want to tell you the general structure over here. We're starting with this, and we need to move forward until we see the other side. All right? So I just want to, kind of talk through this one and just talk through it, kind of briefly, so to speak. I'm not saying it's easy to talk through things either, but you should be talking your way through this as well. So someone says, what did you do over here? Common denominator, A cubed, B cubed, C cubed. What would be in the numerator then? This would clearly be in the numerator. C cubed, B cubed, plus A cubed, C cubed, plus A cubed, B cubed. I got those. Then someone says, what are you going to do next? I'm kind of looking at it. I see that ABC in the bottom. And again, I want to remind you, that maybe I should remind you over here more carefully. We're using this stuff over here. All right? So I'm going to kind of remind you what we get over here. So I definitely have the ABC. I definitely see it. All right, what's the ABC? It's ABC cubed. So what does that mean? Whoops, sorry about that. It means ABC squared, ABC. Okay, what's ABC? It's B cubed. Right, again, this may be more difficult to do, but I can still get it. Now, someone says, what are you looking for to get? I definitely want to get the A squared, B squared, C squared in the bottom. I got that. But now I got to worry about this B cube thing here. So what I do with the B cube is I take it as a divisor and I divide it into every term on top. So if you divide it into this term, what would you get? C cubed. If you divided this term, what would you get? A cubed. I wanted that. But unfortunately, the middle term, I'm getting something that looks kind of crazy to me. So what I want to do is I want to write it down. What would I get? The middle term is A, whoops, sorry about that. I did it again. The middle term is A cubed, C cubed over B cubed. So that middle term, when all the dust settles, can't look just like that. It's got to look like something else. Now I want to point out what it's supposed to look like. I already have the C cubed. I already have the A cubed. I'm hoping to get the B cubed there. All right, let's talk about that. All right, so we're looking at that, and I'm seeing that B cubed, right? And what's B cubed? Well, let's look at it. You're going to get, let's see, a cubed, and then let's write this down over here. A cubed c. Now I don't want to write that down. Let me try something else. Let's try this. Whoops. I'm just using what I know above. And what do you get there? Let's see. I gotta be careful here, right? A cubed c cubed over b cubed. Let me write this down. A cubed c over b cubed. Let's see. I got the c over b, right? Well, let me write this over here. I'm using this fact over here now. So c over b would be b over a. I want to make sure that's true. Yep, that's true. So let's write that down. So what does this give me? It takes time and effort. A cubed and c over b is the same thing as b over a cubed. So this is the same thing as b cubed. I got it. All right, we got it. All right. Now, I got to be honest with you. I actually felt this one, the first one I did was easier than this one over here. This required a little bit of thought and manipulation of those two things that we found, but it's doable. We got there. All right, we got there. All right. Now, when I type things up, again, I want to point out when I'm typing things up, it's not a chicken scratch, but I'll be perfectly honest with you. I actually find typing things easier than writing them down, and I want to encourage you to do that as well. And part of typing stuff up is, you might have a tough time following what people have typed up. But the bottom line is, when I go through all this work over here, all the dust settles, and yes, I use paper and pencil before I type. What do? I start with some initial premises, pick a side, left side, right side. Use those initial conditions that we have, which I believe are kind of obvious, but they may not be until you look at them. And then we kind of manipulate one side to look like the other. In both cases, we either take a left side, make a look at the right side, make a look at the left side. All right? Thank you for paying attention now.